You're appreciated. Okay. Today, I can recognize and represent proportional relationships. So these next few things that we're going to do in Unit 3, you're going to absolutely need in Unit 4. Okay? This is kind of like a prerequisite unit to get to Unit 4. So yesterday I dove into the IO assessment even more than I already do. And Unit 4 is covered about 6 times just in the practice test. So do you suppose it's probably going to be very heavy on the actual test? Yes. Okay. So let's get started. Ooh. I'm feeling very blue. Ooh, purple. Purple. Feeling purple today. All right. So this is CO2. Proportional relationship. Ratios that are set equal to each other. Sounds really weird. I'm going to point it out how you can tell from a graph, a table, an equation. Constant of proportionality. Last year, you guys talked a little bit about that. The ratio between two directly proportional quantities. So we're going to be looking at it in a table, a graph, and an equation. And I'm going to point out how you do that each time, okay? All right. Okay, it says the graph below, but the graph off to the side represents a proportional relationship. Write an equation for the graph in y equals mx form. In Unit 4, we're going to learn y equals mx plus b. We're just introducing y equals mx right now. In algebra, you will use this a lot. Okay, so what it's saying is find the ratio of y to x. Now remember, this is your y-axis, this is your x-axis, okay? So do you see right here there's a dot? Can everyone see that on their paper? Okay, so what would our y value be right there? 3. What is our x value then if we come down? 1. What's a simplified way I could write that? Do I have to keep it 3 over 1? What could I write it as? Just 3. So this right here, when you find this ratio, this is going to be known as our m. It's called our slope. So all I'm doing is I'm replacing that m. A proportional relationship has to go through what's called the origin. Does anyone know what the origin is? In a graph, the origin is right there, that 0, 0. That's the origin, okay? So a proportional relationship has to go through the origin. Okay, so let's try this one down here. So they're asking us to do the same thing. So the first thing we need to do is our y over x. Oh, y over x. This is our m. It doesn't matter. So I'm going to show you this. Here's my y, right? Which is what? 1. And our x is? 4. Okay. Do you see there's lots of other dots here? Okay, let's say I would have done this one. That meant it would have been 2 over 8, right? Does that simplify to 1/4? Yeah. So we always want to go with the one closest to the origin because then it's already simplified for us. Does that make sense? Okay. So now to put it in our equation, as far as a graph goes, do we understand how we're getting our m? Does that make sense? Yes? No? Maybe? So? hot dogs? Not school's hot dogs, so those aren't good. All right. So if you remember, I said we're going to be able to do this a table, a graph, and an equation. Okay. So determine whether or not each table models a proportional relationship. So that's what we're looking for. If so, determine the unit rate. Now, I said every proportional relationship has to go through the origin, right? Which is known as 0, 0. So the first thing I'm going to check every time on a table is if it goes through 0, 0. Zero, 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 zero. So that's the first thing I'm checking. Okay, it goes through 0, 0, so I know it goes through the origin. Okay? So now I know it's a proportional relationship. Now they're saying determine the unit rate. That unit rate, I just like to add another column over here to do my unit rate. Now, the other thing we have to do to determine if this is a proportional relationship is all of these have to have the same unit rate. So we're doing our y over x. So this would be 4 over 1, right? This is 8 over 2, which what does that simplify to? 8 over 2? 4 over 1. This one is 12 over 3. What does that simplify to? Here's how you can do it. Grab that calculator for me. Everyone grab that calculator. If you don't have one, come up and get one. Okay, so right here, I've got my calculator. I can take 8 divided by 2, and notice I get 4, right? Okay. 12 divided by 3, and I get 4. And this is 16 over 4. So 16 divided by 4, and I get 4. So all of these were equal to 4. Do you agree? So, yes, this is a proportional relationship. The unit rate is 4 over 1, which is equal to 4. So my equation is y equals 4x. Questions on this? Okay. Let's go down. We're going to do the same thing down here. We're going to add our extra column. First thing I'm checking, does it go through the origin? Origin is 0, 0. Does it do that? Yep, okay. So now I put my y over my x. I just kind of went down and did them all right now, and then I'm going to come back and divide them all. So we just start at the top. What's 2 divided by 1? It's 2 divided by 1, guys. 2. What's 4 divided by 2? 2. So far, am I doing all right? What's 8 divided by 3? 2.6 repeating, right? Once one of them's different, I can tell you that this is not a proportional relationship. And my proof is right here. I don't even need to write anymore. This is not a proportional relationship, and my proof is right here. How are we doing so far? Does this make sense? Okay. So you've seen one where there is a proportional relationship, one where there is not. What I want you to do is I want you to do A and B there. A and B. Did anyone notice something right away with A? What'd you notice, Kathy?
It doesn't go through the origin.
It doesn't go through the origin. So what does that mean?
It's not a proportional relationship.
It's not a proportional relationship. Can't be. Right here. It has to go through the origin in order to be a proportional relationship. Okay, so looking at that, look at B then. Does B go through the proportional, or go through the origin? Yeah? So this is 0 over 0. Okay, fine, that's our origin. 10 over 1 equals what? What's 10 over 1 equal? 10. What's 20 over 2 equal? 30 over 3 equal? And 40 over 4 equal? So what can you tell me about this? It is a proportional relationship. So then, if we wanted to write the equation, what would we write? Y equals what? 10x. This right here is your M. That's your slope. I can't stress that enough. That's going to be highly, highly, highly important for next unit. Slope. And even next content objective. Questions so far? Doing all right? Okay. Example 3. A proportional relationship is modeled by the equation y equals 5x. So now they're giving us the equation. They're asking us to come up with the table and graph. Okay? So what we're going to do is all of these x values, I'm going to put them in for x. So this first one would be 5 times negative 2. What is 5 times negative 2? You're killing me. Come on. What's 5 times negative 2? Thank you. So the next one, we're going to take 5 times 1. What's 5 times 1? Oh, that's supposed to be negative 1. Sorry. That is definitely supposed to be negative 1 if you want to add that negative in front. 5 times negative 1 gives you? Negative 5. 5 times 0. 0. 5 times 1. And then 5 times 2. Okay? So we were given our equation. We took that equation, turned it into a table. Now what are we going to do with this table? What are we going to do with that table? Nothing? Look at it? Stare at it? Draw pretty pictures around it? What are we going to do with this? Thank you. So it's not draw pretty pictures? Okay, that's good. I can't draw. I'm really bad at it, actually. So we're going to go over to negative 2. 1, 2. Down, and we're going to pretend that we can go to 10. Way down there. But we can't. Negative 1. I don't know why they gave us such a small graph. 1, 2, 3, 4, 5. 0, 0. So right now, do I know it's a proportional relationship? Because did it go through 0, 0? Yes. Over 1, up 5. 1, 2, 3, 4, 5. And 2 up 10 would be like right there. Okay. Questions so far? $1 million. You have to give me the $1 million. No? I think if you all pooled your savings together. Just kidding. Okay. I want you guys to try. Same type of thing. So I'm giving you the equation. Take that equation, put it in the table. Okay, and then we're going to try to graph it. Can somebody tell me what I should fill in my table? So 4 times negative 2 gave me what? Negative 8. Then what's it going to be?
-4.
Then?
0.
Then?
4.
And?
8.
Very good. So now, go over here. I can't go over to negative 8, so I'm going to negative 1. 1, 2, 3, 4. 0, 0. 1, 2, 3, 4. So we graph the ordered pairs and connect the ordered pairs with a line. What is the unit rate for this proportional relationship? What was the unit rate? What's in our M spot in our equation? What's in our M spot? 4. Our proportional relationship is 4. Okay, we're almost done, guys. We're getting there. Got a little bit left and we're done. I think we got 2 left. Yep. Okay. The McDonald and Jefferson families both went camping last weekend. The information below shows the relationship between the number of minutes, X, they drove and the number of miles driven, Y. After an hour of driving, how much further did the McDonald family drive compared to the Jefferson family? So see, we've got 2 things here, right? So we kind of got to organize this. Here's my McDonald family, right? What's their unit rate? What's in the M spot? 1.25. Okay. All right. Now we need to find the Jefferson unit rate. So it's Y over X, remember? So what's our Y? 3. And what's our X? 4. So when I divide that, I get 0.75. So, oh, I'm sorry. Thank you for letting me know that. I appreciate it. Okay. Now, we have to look at the question. We've got both unit rates. Now we have to look at the question. After an hour of driving. Now remember, X stands for minutes. And they're asking for an hour. So I got to put that in minutes. How many minutes would that be? How many minutes are in an hour? 60. So we're going to do the McDonald family. We're going to say y equals 1.25 times 60. And then we need to do the Jefferson family, but their unit rate, remember, is 0.75 times 60. Right now, all we're trying to do is figure out how far they drove in an hour. So we get it out, 1.25 times 60. They drove 75 miles. The McDonald family did. Now let's figure out how far the Jefferson family drove. I get 45. Is that what you guys get? What's the question asking, though? How much further did the McDonald family drive? Have I answered that right now? So they went 75 miles. They went 45 miles. What should I do to get how much further they drove? Subtract. And what do you get? 30. So the McDonald family drove 30 miles further than the Jefferson family. I promise you when you start to do ones like this, it's going to be helpful to kind of organize this. Okay. Sarah mowed lawns. The equation is y equals 15x. Represents a relationship between the number of lawns she mowed, x, with her total earnings, y. Jared also mowed lawns. His earnings are shown in the table. Who earns more per lawn? So you know Sarah. How much does Sarah earn per lawn? Huh? 15. So we already know that Sarah earns $15 per lawn. You need to find Jared's unit rate. I get 12 over 1. Do you agree? Which equals what? 12. 24 over 2, which equals 12. 36 over 3, which equals? And 48 over 4, which equals 12. So, Jared, how much does Jared earn per lawn? $12. Who makes more then? Who earns more per lawn? Sarah. What do we think? Think we can handle CO2? It has to go through the what? In order to be a proportional relationship. Origin. And what is that coordinate number? 0, 0. Awesome work, guys, today.